our webinar on Introduction to Google Cloud Platform. My name is Chirag Thapar and I'm associated with Sela as a lead for cloud sales. Today we are going to deliver a 1-hour session while showcasing the insights of Google Cloud Platform services. Before we kick off the session, I want to introduce you all with Sela Technology Solutions. Sela Technology Solutions India Private Limited is an Indian entity of Sela Group, which is a 3-decade young IT MNC and headquartered in Israel. Besides India and Israel, we have an existence in US, Canada, and Singapore as well. Sela Group is a technology company for past 3 decades, serving over 800 clients across the globe with around-the-clock model in various industry verticals for software development, technology consulting, cloud computing, technology training, offshoring and outsourcing, as well as product development. Sela's relationship with cloud started almost 10 years back with Microsoft Azure. Sela was the first company worldwide to train on Microsoft Azure. More recently, Sela is also providing cloud consulting on GCP as well as on AWS. Since this session is going to be focused on Google Cloud Services, I can't get myself away without speaking about Google's cloud infrastructure. Tell a bit about Google's cloud business expansions in recent times.
Talk about Google's infrastructure a little bit. Google infrastructure consists of custom-built machines. So the data centers are do not contain any machines that are off the shelf or bought off the market. These are designed specifically for Google data centers. They're designed for extreme efficiency in terms of performance, even in terms of energy consumption. They're designed to reduce number of potential vulnerabilities. Google Cloud Platform provides live migration. Your VMs don't need to be rebooted for host software updates or other standard operational tasks. Instances can be moved to nearby hosts even while active. This is the kind of future-proof infrastructure that Google provides. Not only this, Google also has a host of no-ops services. Now, we all know that normal cloud computing, what we generally understand as cloud computing, removes the necessity of buying and maintaining physical infrastructure. The Google Cloud Platform provides services that go beyond being infrastructure as a service. This provides a complete set of managed services that remove the overhead of managing and monitoring your virtual infrastructure. These services provision infrastructure as and when needed, thus removing any bottleneck for scaling. Normally what happens is when you want to scale, the first thing you need to start thinking of is infrastructure. But these no-ops services or managed services remove this bottleneck completely. And there are a lot of these services. There's the data warehouse as a service, ETL processing as a service, platform as a service, messaging as a service, and even machine learning as a service. All of these are no-ops services, and we'll be introducing you to all of these shortly. Lastly, what Google Cloud Platform offers is machine learning. Machine learning is what makes computers and systems intelligent and perform smart tasks, like translating, understanding pictures, doing some kind of predictions, recommendations. Now, this kind of intelligence has been Google's forte, starting from context-sensitive ads. Google has also built large models with the data that they have been collecting, and they're making these models available to all of us. They're also offering us Cloud ML, machine learning as a service. Now, using this, you can create your own models and apply machine learning algorithms to them. And all of this is as a service. Again, no infrastructure or provisioning needed. So let's start digging a bit and get details of the services available. At the very base of any cloud service provider is infrastructure. Google Compute Engine is Google's offering in the infrastructure as a service space. And this service checks all the offerings that you need to meet your organization's infrastructure requirements. Compute Engine offers virtual machines, and in this virtual machine, there's a fair mix of standard, high memory, and high CPU combinations. And just in case you need a combination of CPU and memory that is not off the shelf, you can always create a custom machine with whatever configuration you need. Similarly, all the other pieces of infrastructure as a service are also present. You have persistent disks, you can take snapshots, you can store VM images, you have all the needed networking options where you can create forwarding rules, VPNs, firewalls. There's a global load balancer, global DNS service, In short, everything that is needed for standard systems infrastructure are available with Compute Engine. And then there are a little bit more advanced features, such as being able to create instance templates. These instance templates define machine types, image, zone, etc. And then you can use these to create instances. Generally, these are part of a managed group, and managed groups allow you to manage a bunch of VMs as a single entity. You can then use these instance groups to apply auto-scaling policies. These can be based on CPU utilization, load balancer serving capabilities, or any other monitoring metrics that you think of. Based on this policy configuration, the platform will add more instances or reduce the number of instances. In addition to all of this, Google Cloud Platform also provides preemptible VMs. These are short-lived compute instances suitable for batch jobs and fault-tolerant workloads. These are similar to normal VMs, except they last only for 24 hours. So what do you use them for? Batch processing jobs. The advantage, they're 80% cheaper than normal instances. So this was about infrastructure as a service. Moving on to platform as a service, one of the constructs that makes platform as a service feasible are containers. And Google Cloud Platform provides Google Container Engine for this. Google Container Engine is a powerful cluster management and orchestration system for running your Docker containers. This container engine is based on Kubernetes, and Kubernetes is an open source platform for automating deployment, scaling, and operation of containers. Kubernetes is something that has come to Google Labs and is now open source, which also means that you can very easily migrate providing support to open source community and making sure you're using Google Cloud Platform, not because you're stuck to it, because it has a host of rich services available. Anyway, coming back to Container Engine, it has a rolling updates feature. With this, you can roll out new features seamlessly without any downtime. In addition to auto scaling, which is configuration based, the Container Engine also provides for automated container health checking. And with all these features, application maintenance and monitoring overheads are almost completely removed. So that was Container Engine. Moving one step ahead in the platform as a service space is Google's App Engine. While Container Engine provides a very efficient way of managing and orchestrating containers, you still need to be aware of how containers work and what are the basic needed configuration. But with Google's App Engine, you have a true platform as a service. You don't need to be aware of any kind of underlying infrastructure at all. All you do is code, build, and deploy. It's that simple. Google's App Engine takes your application code, deploys it, monitors it, and provides auto-scaling of your application. There is no need for any installation, provisioning, or configuration. Google App Engine was the first offering of Google Cloud Platform to the market way back in 2008-2009. However, at that time, the market was not ready for this. The market was more looking at virtual machines and infrastructure as a service. And so Google decided to offer what the market wanted, and that was Compute Engine. So in fact, Google has gone back to infrastructure as a service while having started with platform as a service. Anyway, coming back to the App Engine supports any kind of programming language or framework. You can bring your own programming language, that's what they say. Google App Engine supports modular structure, making it easy to build microservices-based systems. With the App Engine, you do not need a separate staging or testing environment. The App Engine supports application versioning, and with each version having a separate URL, you can test them separately. Google App Engine also supports traffic splitting that helps in A/B testing and incremental feature rollout. The way this works is you can configure a certain percentage of traffic based on IPs or cookies to go to a newer version. Once all the tests for the newer version are complete, all 100% of traffic can be routed to this version. In addition to this, App Engine also has built-in support for cron jobs, task queues, memcache, everything needed to build a proper, simple application. So now that we have looked at Compute Engine, Container Engine, App Engine, we need to check what are the options available in the database section. And here we have Google Cloud SQL. This is Google's offering for database as a service. Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage, and administer your relational PostgreSQL or MySQL database. All backups are automated, all patches and upgrades are applied seamlessly. Replication can also be configured very easily, and Cloud SQL supports up to 5 read replicas. Cloud SQL also provides a high level of security. Data is encrypted when in Google's internal networks, when stored in database tables, temporary files, backups, encryption keys and master keys encryption is all managed automatically by Google. In addition to RDBMS, the other small piece that we need in building applications is the NoSQL database. Google also supports NoSQL database as a service, and this service is called Google Cloud Data Store. Now, this is a highly scalable NoSQL database that supports automatic sharding and replication, helps making your application highly available and durable. Cloud SQL is one of the few NoSQL databases that support ACID transactions and SQL-like queries. It has a RESTful interface and is also supported by some community-supported ORMs such as Objectify and NDB. Cloud Data Store has a comprehensive dashboard that allows you to view entity statistics, query your database, view indexes, and backup and restore your data. So this is Google's offering in the NoSQL database as a service. So in addition to compute and database, Google Cloud Storage provides global, elastic, and cost-effective storage service. This service provides options for storing live data to data archival, everything that you need from your normal web applications data to archival data. Everything can be stored using Google Cloud Storage. This also allows you to enable object versioning. Once enabled, a history of modifications of overwrite or delete of objects is kept for all the objects in a bucket. You can define lifecycle management policies, such as keep the 5 recent versions of objects, or delete objects older than 3 months. All of these policies can be applied, and Google Cloud Storage performs automatic actions and applies these policies. A client application can also send a request to watch for changes to the objects in a particular bucket. So whenever an object is added or deleted, a notification is sent via a URL to your application. Google Cloud Storage also has a cloud storage transfer service. This enables you to import large amounts of online data into Google Cloud Storage, and this could be coming from any other sources such as Amazon S3. There are various tools available for offline import as well. And coming down to various storage classes. The various storage classes that Google Cloud Storage provides and that are available for you to choose from depending on your needs are regional storage, multi-regional storage, nearline, and cold line. Regional storage enables you to store data at a lower cost with the trade-off of data being stored in a specific regional location instead of having redundancy. If you want redundancy, you go in for multi-regional storage, which is geo-redundant. That means Google Cloud Storage stores your data in at least 2 regions. Nearline is a low-cost, highly durable storage service for storing infrequently accessed data. It is a better choice in scenarios with slightly lower availability, a 30-day minimum storage duration, and cost for data access are acceptable trade-offs. So you can store your data, which is accessed maybe once a month. For such kind of data, Nearline is a good solution. And Coldline is a very low-cost, highly durable storage service for data archiving, online backups, and disaster recovery. Unlike other cold storage services, in case of Google Cloud Storage, your data here is available within milliseconds. It does not take hours or days for you to fetch your archival data. So what we have seen so far is really automation of the traditional way of application development, deployment, and management, which is just aided by the cloud. In this scenario, the application building blocks remain the same. There's the front-end layers, the storage, the traditional RDBMS. All of these are more or less the same from about a decade ago, except that the overheads of installing, managing, and maintaining these are greatly reduced, if not removed altogether. But what does the future look like? What will be the building blocks of future applications? And this is where next-gen computing of no-ops services comes into picture. There will be newer and better services available as application building blocks, using which we can create applications that can scale massively with absolutely no management overheads. And these are the services we'll be talking about next. And the first amongst this is BigQuery, one of Google's most impressive no-ops services. This is a data warehouse as a service, and in an age where we have an explosion of data coming in from various sources at different speeds, at different formats, managing this data, querying it, and managing the resources to store this ever-increasing data is quite a challenge. This is where BigQuery comes into the picture. BigQuery is Google's fully managed, petabyte scale, low-cost enterprise data warehouse for analytics. This is extremely fast. How fast? It can scan terabytes of data in seconds and petabytes of data in minutes. If this were not enough, BigQuery is also serverless, which means there is absolutely no infrastructure to manage, no storage provisioning to be done. You load your data from cloud storage or cloud data store or cloud SQL, or stream it into BigQuery. You run simple SQL-like queries, and you have almost real-time analysis of your data. You do not need to do any partitioning or configuration of your data for better performance. With this, you can easily scale your database from gigabytes to petabytes. And all of this using standard SQL queries. So you do not have to learn a new programming language or tool either. So that is data warehouse as a service, BigQuery for you. Now you have all this data coming in from various places, various sources, and that too at high rates. And how do you manage this? How do you handle all of this data coming in? To address this challenge, we have Cloud PubSub, Cloud Publish Subscribe. It's a publish subscribe model. It's a fully managed real-time messaging service, a global service allowing you to send and receive messages between independent applications. This service supports both push and pull delivery. In case of pull, you request PubSub to send you unacknowledged messages. In case of push delivery, all subscribers are notified of a message arriving. Now, subscriptions can be one-to-one or one-to-many. By building on the same technology that Google uses, so this is something that Google uses for its own services internally as well, Cloud PubSub is designed to provide at least once delivery. So any messages arriving to PubSub are guaranteed to be delivered to your subscriber at least once. And if you talk about speed, PubSub can process 10,000 messages per second. This is the standard default speed that it has. But what if your application needs more? You can always demand for more computing power, and Cloud PubSub for your project can scale up to 1 million messages per second. So far, we have seen how huge volumes of data can be ingested through PubSub, and how huge volumes of data can be stored and queried in BigQuery. The missing part of this puzzle is how to process incoming data such that it is easily understandable in a standard format, and it can be loaded into any analytics system, especially like BigQuery. And this piece is Google's Cloud Data Flow. This is Google's offering for ETL as a service. Data Flow is a unified programming model and a managed service, again, for developing and executing a wide range of data processing patterns. This could be for batch or for continuous computation, or for example, streaming data. This is probably the only one of them in which the same kind of programming model can be applied for batch as well as streaming data. The programming model is provided by Apache Beam, which is open source. Since this is a completely managed service, all the needed resources are provisioned and scaled automatically. Now, depending on the complexity and amount of data to be processed, data flow scales horizontally, creating the required number of worker resources called runners. The number of runners needed are calculated at runtime to ensure optimum throughput. So again, what you're doing here is writing your ETL code, deploying it to the cloud. The cloud platform takes care of scaling your application, scaling your data flow pipeline, provisioning resources for your application to work all automatically. Absolutely no management overhead needed here. Now, in addition to all of this processing that we have seen, when it comes to machine learning, Google also provides a lot of pre-built models for specific purposes that can be accessed through APIs. All the APIs that I have listed here, translate, speech, vision, and NLP, I'm sure all of us have used some or the other of this at some point of time. Translate API, I'm sure you must have all used this. It's translate.google.com. It dynamically translates text from one language to another and supports 100 different languages. It even provides language detection capabilities. And all of this can be accessed through REST-based APIs. Speech API lets you convert your speech into text. This supports over 80 different languages. Vision API enables you to understand the content of an image. It detects individual objects, faces, even text residing within images. If you're using Google Photos, you're already using Vision API. Next comes the NLP API. This API reveals the structure and meaning of text. You can use it to extract information about people, places, events, and much more mentioned in text documents. You can also use it to understand sentiment about your product on social media, customer conversation. With using this API, you can understand whether the tone of a text is angry, sad, happy. All of this with NLP API, a REST-based API. So all of these are based on pre-built models that Google has built. What if you want to build your own data model? What if you want to convert your data into something more meaningful and use it in your own applications? For that, we have Cloud ML, a Google Cloud machine learning engine. This is again a managed service that enables you to easily build machine learning models, and this model can work on any type of data of any size. Since this is a managed service, you do not have to worry about provisioning or computing or storage or anything. Any infrastructure in terms of GPUs, CPUs, or storage will be automatically provisioned to run and create your data models. And this is not all. Google keeps on adding newer and interesting services to its offering. It has cloud functions that you build and deploy services at the level of a single function, not at the level of entire applications, containers, or VM, simple small functions. And this provides a serverless environment for computing. Google has recently announced GA of Cloud Spanner. Now, traditional RDBMSs, as you know, provide vertical scalability with strong consistency. NoSQL databases provide horizontal scalability with eventual consistency. But Cloud Spanner is the world's first fully managed relational database service to offer both strong consistency and horizontal scalability. So this can be used for a lot of mission-critical OLTP database systems. And the most recent offering from Google Cloud is IoT Core. Cloud IoT Core is a fully managed service that allows you to easily and securely connect, manage, and ingest data from millions of globally dispersed devices. So given all of these services, any kind of application you need to build, Google has some or this service available to make your life easier. But how do you tie all of these services to build your applications? For this, we have some sample application architectures. I will now hand over to Yogesh Golande, a solutions architect, who will talk to you about a few sample application architectures.
Okay, so thank you, Vishaka, for such an amazing introduction to the world of Google's cloud platform. So as Vishaka introduced, my name is Yogesh and I work as a solution architect in Seva Technologies. Now I know that we went through a lot of important services one after the other. So before we dive into the world of architectures and see which services fit where and why, let us quickly summarize the services that we have seen till now. So if you see, the services are basically divided into four broader categories: compute, storage and database, big data, and machine learning. So under compute, we have Compute Engine, which is infrastructure as a service from Google. You basically manage the entire infrastructure, you have VMs and other stuffs. Then we have Container Engine, which is container as a service from Google, wherein you manage Docker containers and their clusters using Kubernetes. Then we have App Engine, which is platform as a service from Google. So you just forget about the infrastructure and DevOps hassles and just focus on your development and product. Under storage and database, we have Cloud Storage, which is a managed NoSQL database. We have Cloud SQL, which is fully managed RDBMS database supporting MySQL and PostgreSQL. And at the end, we have Cloud Storage, which is cost-effective object storage service from Google. Now in the analytics part for big data, we have BigQuery, which is Google's fully managed petabyte scale low-cost enterprise data warehouse for analytics. We have Cloud PubSub, which is a fully managed real-time messaging service. And we have Cloud Data Flow, which is a managed service for ETL. And at the end, we have some fancy machine learning algorithms, which translate speech, vision, NLP, Cloud ML. As Vishaka mentioned, you might have used them at certain point in your life. So now let's dive into the world of architectures. And the very first architecture that we are going to discuss is probably the most common use case, which is deploying web applications on Google Cloud. Now, any basic web application consists of a front end, a back end, but when it comes to a production grade environment, there are whole other aspects that you need to consider, like how much load can your web application handle? How will it respond to failures? How your front end as well as your back end will scale, and so on. So these are the considerations on the technical side. Now on business side, you need to consider whether you are a huge organization which has expert resources in handling infrastructure and DevOps, or you are a tech savvy startup who rather wants to focus on your product development and its features. So considering all the above aspects, the best architecture that you can go on GCP is to use managed services as much as possible. So let's drill down and take a look at what this architecture contains and the reason behind we are using the services that we have used. So in this, you can see that on the front end of the client, you have a browser, you have got various mobile applications, Android, iOS, and so on. Next, you can see at the entry point, you have Google Load Balancer, which is used to distribute the incoming traffic. You can also optionally use Cloud DNS if that is something that would be necessary for your solution. It is nothing but a managed DNS service from Google. Now, the main application is basically divided into a few core components. So the first one that we're using is App Engine, which is your front end. Now notice that it has auto scaling turned on, which is by default in case of App Engine. So now why App Engine? So the reason to use App Engine as a platform or a managed service when hosting web applications is when you will have a spiky traffic or exponentially growing traffic, and you don't want to worry about manually partitioning then scaling, and instead want to just rent and use the service that Google Cloud provides it for you and scales it for you. So for example, consider a social media kind of a startup which plans to have event around launches of movies and other type of entertainment events or sports events where the traffic would be really spiky and even they don't know how large this can grow. So rather than having an infra and DevOps team to worry about the infrastructure and scaling part, they can just focus on the functionality of their application by using App Engine. So along with this, it is pretty common to use some sort of caching mechanisms so that some aspects of your application can render even more quickly. So for this, Google has Memcache, which is a managed caching service that you can integrate in your front end in the App Engine, which you can see it over here. So this was about the front end. Now let's have a look at the backend architecture. Now in the backend, you can see that we have used different services for static as well as dynamic contents. So we have used Cloud Storage, which is Google's managed object storage service that hosts some static content. And the reason that we are using this is because it is super cheap and very simple but powerful object storage service. It is highly durable, scalable, available as well as consistent. Now, if you look, even for the dynamic content, we have used two different services. So we have used Cloud SQL for a transactional or RDBMS kind of data, transactionally consistent data. And we have used Cloud Data Store for the eventual consistent data that consists of entities. So why this approach? Now, if you look at it, this is slightly different from the traditional approach which was being followed so far, which was using a specific type of storage service and then partitioning the data within that service. Instead of this, the new approach is to use or partition the data amongst the services instead of doing it within a service. So what do we mean by that? So if you look at it, we have basically partitioned the data into different services. So we have stored some static data or blob data on the cloud storage. We have some relational data in the cloud SQL. We have some eventually consistent data in the cloud data store. So this is basically a new approach as considered to the traditional one. Now, in addition to all of this, your web application might also have some other tasks which it may process offline or separate from the front-end application. For this, you have task queues, which can schedule this asynchronously. And for you can use a second application to do this offline processing. You can use, over here you see that we have used the same App Engine platform. You can use Compute Engine wherein you have your instances and you can just deploy that batch application in that. The main reason to focus over here is that you separate the processing of rendering the application and this batch processing into two different components and don't mix their performance together. So well, this is how a typical web application architecture will look like on Google Cloud. Of course, you can grow it more depending upon what your requirements are. You can, if you want analytics as a part of your web application, you can add BigQuery over there. If you want to perform some serverless computing over it, you can use Cloud Functions over there. But let's check some other solutions or use cases for this wherein these services will be more apt fit. So the second architecture that we would be considering is real-time stream processing or an IoT-based solution. So IoT is the next big thing in the industry today, and it pretty much covers all domains or sectors: industrial, medical or healthcare, building and automation, energy, and so on. So now in any basic IoT solution, we have a fixed set of components or stages. We have certain IoT devices which are streaming some or the other form of data. These devices can also receive control or data signals. Then we have data ingestion process to fetch the data from the streaming devices. We process the data, we convert into some kind of required format, and we store the data. Now, once we do this, the next part is presenting the data or the data readings or the real-time statistics. So this comes under the presentation part. We also do some kind of an analysis for the data because that is the crux of using the IoT for such industries. So for this, we use data analytics solutions or services. And optionally, we can also include machine learning on it so that we can use all of this gathered data to train the control behavior of the devices or the application. So let's take an example. Let's take an industrial solution wherein you have various sensors like temperature sensor, pressure sensor, etc., which are getting the readings, and the IoT devices continuously streaming these sensor data. So you have a factory which is wherein all your machines have been integrated with sensors, and the devices are sending the information which is crucial to you, which will be used to, let's say, determine if it needs maintenance and so on. So now let's see how we can build an architecture using GCP components for a case like this. So we'll basically look at two different architectures. There is one service which is recently released by Google, which is still in private beta mode, which is the Cloud IoT Core. So this is why we will consider an application which are using the existing services which are available to everyone so far, and then a separate architecture, an improved architecture of how it will look like using this upcoming service, which would be GA in a couple of months. So this is the first one. So if you look at this, consider this area as the IoT devices. You can have standard devices which communicate via HTTPS, or you can have constrained devices which basically communicate via non-TCP protocol. You might know them as BLE. Let's say they communicate via Bluetooth. So all of these devices would be communicating to the cloud platform using the gateway or an IoT broker. So now, once we gather the data, the first step is the ingest part. This is where the cloud pops up. Would be a very apt service because it is a managed messaging platform. It lets you ingest data at a large scale in parallel. So once we get the data, then the next part, as we discussed, is processing or formatting the data in the way you want. This is where the cloud data flow comes to help, which is a managed ETL service. So you just load, transform, gather the data. Once you have done the processing, the next step is to decide where you want to store the data. So like we discussed in the previous architecture, you can choose a particular write storage solution or a set of storage solutions depending upon what the data is. You can store part of data in cloud storage. You can store part of data, a NoSQL data in cloud data store. Or if there is analytics specific data, you can store the data in BigQuery, which is here. Next comes the presentation and the application part, wherein you would actually be presenting, let's say, a dashboard which shows the real-time numbers gathered from the sensors. So again, you can build your application using App Engine, or if you want to have some control over the infrastructure, or you have an existing application which is ready, you can just deploy it on a Compute Engine instance. So these can just talk to or fetch the data from the write storage devices and then present the data accordingly. For the analytics part, we have BigQuery, the data warehouse solution, and you can use Data Studio. I know that this wasn't covered, but this is basically a managed a reporting tool which lets you build, gather the analytics data into informative dashboards or reports that are easy to read, easy to share, and fully customizable. So this is how it will look like using the existing services that we have. Now let's look at Cloud IoT Core, which is a new service from Google. So basically this is a fully managed service that lets you not only easily and securely connect, but also manage the devices and read data from the globally dispersed devices. So it just has two main components, a device manager which will control the device and a protocol bridge which will fetch the data using the standard MQTT protocol from the devices. So the remaining part will pretty much be same, because that's how the phases are. So you connect to the devices, you fetch the devices into the IoT core, then it sends to Cloud Pops Up. You have both the options of doing an ETL on the data, storing the data, performing some kind of analytics on it using the same Data Studio solution. You can use App Engine and Compute Engine to build the application presentation, web applications. You see over here, we have Cloud Functions, which is the serverless architecture service from Google, wherein you can perform some device updates if you want to control the device, if you want to send the control signals to the device. And another different that you will see over here is the use of cloud machine learning. Now, let's consider a scenario. So far we have been using IoT and this architecture for fetching, analyzing, and representing the data. But you can go a step further and train the way you manually train your system to perform the same manual task that you do after looking at the analytics results or after looking at the real-time data in the dashboard. So let me consider a different example for this. I'm sure you might have heard of home automation IoT solutions, wherein you can control all the electronic equipments at your home using the IoT solution. So there is a device which is connected to the power board or other electronic devices that you have, and basically you can just control it from a smartphone application. And it also lets you gather the statistics of how much electricity or power each device is consuming and other stuff. So now consider a situation that each and every individual user has some of the other patterns of it. So for example, a particular user arrives at home only at 7 o'clock in the evening and turns on the light or starts his music system to listen to his favorite songs. Now we can go a step further in this solution and use cloud machine learning to gather all of these patterns so that we can train our application to either recommend or do the behavior for the user on his behalf. So then once the device is turned for the individual user, the user can then, let's say when at 7 o'clock or a specific time of the day, it can start the lights, it can start the music, play the songs that user has more preference to, or can recommend those things to the users. So I think we covered pretty much the important services in these two architectures, and because of the time constraint, these are the two architectures that would be referring to for now. So we all want to thank you for attending this webinar, and now we'll start taking questions. I request you that you can use the questions or chat box to put the questions. You can just add your name and put the question to make it more efficient. So let me see, I think we have some questions. Okay, so we have a question from Anand. Anand is asking, please can you elaborate on the serverless concept part? So the way it works is in Google Cloud, they're known as cloud functions. If you worked on AWS, you might have heard them as Lambda functions. So it is a bit different from the platform as a service approach, wherein you can write a small piece of code and the cloud platform will, at the right time will just put the piece of code and on the right environment and process that for you.
But actually, serverless concept goes beyond just cloud functions. If you look at all the other services we talked about, for example, BigQuery. Now, in case of BigQuery, you're not really requesting for a VM. You do not know where your data is stored. All the computing and the storage is happening seamlessly. This is what serverless concept is all about. This is what serverless means. So basically, a traditional application deployment approach is you write your application, you get hold of a VM, you install your OS, your software, you attach your disk to it, and then you run your application. But in a serverless concept, what you're doing is basically just deploying your application and running it. You're doing absolutely no infrastructure management. And this is available in Cloud Functions, in App Engine, in BigQuery, Dataflow, even Cloud Machine Learning is serverless because you are not provisioning any infrastructure at all. Okay, the next question that we have is languages supported by App Engine. So all the languages are supported. You have your usual languages like PHP, Python, Java, Go. But basically, there is no restriction on the languages that you can have. Underlying infrastructure is basically containers. So you can specify and bring any kind of languages that you want to the platform.
Okay, so the next question is any advantages of using Google service over AWS? Yes, we have a lot of them. As Vishaka mentioned in the beginning, since Google came late to the party, the most important advantage that Google has over other cloud service providers, not just AWS, is the pricing mode. First of all, they're cheap. Their pricing strategy is different. All the other cloud service providers charge you per hour. Google bills you per minute. When it comes to discounts, for example, AWS has a constraint wherein you will have to choose for a reserved instances. You will have to choose a commitment for 1 year to 5-year period wherein you can pay partially upfront or full upfront. Google also has those options, but along with that, Google has the options, a concept of sustained usage discount, which is wherein you start getting discounts if you use the instance for more than 25% of period of a month. So there are no conditions accordingly. This is from the business side. From the
technology aspect, there are a whole lot of services. All these no-ops services are actually purely no-ops. Some of these services, if you compare to the equivalent in AWS, you realize that you do have to do some kind of configuration. Redshift, for example, you have to do some kind of data partitioning and some configuration to make sure that you get consistent performance. Whereas in BigQuery, there's absolutely no such configuration required. They're absolutely 100% no-ops services. Okay, another question that we have is, can you explain a bit more on Cloud PubSub services? Okay, so this is, as we mentioned earlier, messaging as a service. It is essentially a publish subscribe model. So what happens is you create a topic. I'm going a little bit more into technical details here. You create a topic, and there are people who subscribe to this topic. By people, I actually mean applications, microservices, who will subscribe to this topic. And then you can have other systems, other applications. In case of an IoT device, you could actually have the device itself posting to this topic, publishing to this topic. And you have all these subscribers who will be notified of this, who will take this notification and do some kind of processing on it. So for all those who have used JMS, this is the equivalent of JMS, except it is a service on the cloud. I hope that answers your question. The next one is, does BigQuery come with any security mechanism to handle sensitive data and confidential data, especially for financial and pharmaceutical companies? In Google, actually, Google Cloud Platform itself, all the data is always encrypted in flight as well as in rest. Okay, so it is every time encrypted and secure. Google has all the usual precautions of allowing you ACLs, so you can decide who has access to your data and what data. So I think this kind of security should be enough for any kind of system. Regulatory wise, yes, Google Cloud Platform is HIPAA compliant. So all of these, plus it has a whole lot of security certifications as well. So all of these usual needs are tick marked or check marked in case of Google Cloud Platform. The next question is, can Google App Engine application use Cloud SQL without using its implicit data store? Yes, of course, it can. You can use normal JDBC to connect to Cloud SQL and use it in your App Engine. We have time for one last question. Okay, is Google Cloud Platform supports open source operating system? Yes, of course it does. All the open source operating systems are supported. Windows is also supported, but you have to pay your license cost. So, okay, so I suppose that's it for now. Thank you everyone for participating in this webinar. Stay tuned for our next webinar, which we will be announcing shortly. It will be a bit more detailed on a particular set of services, and we will inform you of this webinar soon. Thank you everyone.
Thank you guys.